Howdy, everybody. Are we live? Mr. Investor baby. Let me know if you guys can see me. Let's do an audio check. Mic check 1 2 1 2. Ooh. Who's ready for this, baby? Oh yeah. How many people we got in here? Hello, everybody. I'm still trying to see if they're ready to rumble. Currently clicking on it in the lobby and trying to see if we can get in, baby. Maybe they're not ready yet. Oh, you see me? I see you too, Keaton. Sup, cowboy? Let's go, Bingo Rangers. Oh yeah, I see you now. Yeah, I see you, bro. What's up, cowboy? Bingo Cowboys. Oh, my soldier boy, is that you? Is that you, soldier boy? Hello. Oh my goodness. Alka is a rock star. We're just waiting for them to be ready, really. They're kind of quite thin. There's 3 minutes till kickoff and we can't really clickety click. You want to see? I'ma show you, baby. You want to see? I wish they did, man. I wish they did. What's going on, everybody? Take a look. Take a little sneaky peek. It's what I'm currently looking at. So we're just waiting for them to get ready. Hopefully we can get into that because it looks like we're clickety clicking. It ain't clicking yet. Hey, what's going on? Oh, it's the messenger of Moistville, the Bingo Cowboy. And Vibes in the house. Vibes is vibing. What's going on, everybody? Davey. My portfolio took a knee to the head, bro. Come on, Kathy. Hook it up, baby. Oh, my God, Mr. Wu. Kevin Wu is in the house. What's going on, everybody? Oh, it's Sean O'Sullivan in the house, baby. And Kev as well. Yeah, literally, we're just waiting. They're cutting it close. Whoa. Trying to clickety click still and ain't got nada yet. Oh, baby. Moist vibes, baby. Double up, said Rafi. Moist vibes. It's Chris Brown, so breezy. What's going on, everybody? You're so moist. You know what? People hate that word, you know? They hate that word. They're like, oh my God, he's moist, man. I'm excited, literally. I'm hungry to get into this. I really want to see what they're going to say. Super, super. Chicken nuggies and nano nozzles. What's going on? Get that honey, baby. Want to hear about that honey? We're still waiting. Oh, Bionano's happy hours there. Click join by clicking the lobby sign. Well, we clicking. We spam clicking. Or we click here. Oh. Oh. It looks like your sign's been... Your hyperlink isn't working, sir. Come on, let us in. Refresh the lobby. Let's go to the exhibit hall. And then come back to the lobby. Oh my goodness. Still ain't working, guys. Let's go, bingo. Messenger shows you know you're doing legit stuff. Thank God. I hope we can get in, boys. It looks like the link isn't working, though. I wonder if they're watching, too. I think Bingo's watching this live stream as well. Oh, my goodness. Come on. We excited, but we don't know. Wonder if they're having technical difficulties or if they're giving us technical difficulties. Baby. Yo, what's going on, guys? Alka and Homlin's gonna join here. Listen, man, we can't get in for some reason still. Oh, baby. Hey, yeah. Man, it's cooking up this March, isn't it? We're gonna have this earnings cupping up. Why can't we get in? Is the question. Maybe their link's busted. No clickety click, boys. Ain't looking good. Earnings report coming up. Depends completely on future projections. Oh, baby. I think we're gonna have even better earnings report on the quarters after. I'm still trying to figure out why this won't click. What do you reckon, boys? What do you reckon? Click this one. Nope. Is anybody on Twitter right now? See if AGBT is having technical difficulties or if everything's still popping off. Simon hacked it. Simon said he don't want to see us. He don't want to see us in the party bus. You guys give me jokes. Oh, come on. If anyone's on Twitter, yeah, we're all registered here, man. Everybody's registered who got into this place. We all had to pay money, man, cash money. But why can't we get in? Thank you, guys. I appreciate everything you do. If anybody's on Twitter right now, can you check if AGBT is having technical difficulties, or if Bionano Genomics has said anything as well? Because right now we're outside the lobby. We're still in the lobby. Restart the lobby. Yeah, let's do it. Have a little refresh. Oh my God. Oh, we're in Zoom, baby. I gotta close up. Whoop.
Story. We're in the age of big biology, the age of contextual biology. Some say that big biology will be as big a story as sequencing has been, which makes me very pleased to be interviewing two leaders of Bionano Genomics, the genome mapping company. Erik, CEO, and Alka, CMO. Welcome. So I've interviewed both of you before, I think a couple times each, and now here you are together at Bionano. It's really great to be with both of you.
Thank you, Daryl. Great to be with you.
So our slot here on the program, I noticed, was titled Virtual Happy Hour. So I guess we're the end of the day party here.
Yeah. We should stay hydrated. Stay hydrated.
It's up to us to keep it fun. So Erik, Bionano is coming off a fundraise of nearly $400 million early this year. Wow. Can I say that again? $400 million. Perhaps that's really what's meant by big biology.
There's some truth to that. There's some truth to that. Innovation is not cheap, and so capital is required. But we're at a time where people who are putting capital to work are recognizing the potential that lies ahead in genomics. And so they're getting behind companies like Bionano and many others to really give us the fuel we need to drive the big biology.
Yeah. So you can give instruments away for free now, right? Like sequencing companies.
That's not how we rehearsed it, but sure, we have money, and if people make a commitment to using reagents, we'll happily put an instrument in their lab.
But seriously, the stock's been going up. Things look like they've been very good. And it sounds like a verification of big biology and structural variation. You and I talked about it a few years ago. Why does structural variation still feel like a new thing?
I mean, it's a great question, and I have my views, and I would love to hear what Alka says. I think structural variation is a little bit of a sequencing term. I think in sequencing, we think about sequence variants, single nucleotide variants. And so naturally, when we start to think about chromosomal rearrangements, the idea of structure and structural variation comes in. In the early days of the Human Genome Project, which is why we like to remind people to go back to the map, it was a fundamental principle to think about how the genes and other functional elements of the genome were organized on the chromosomes, across some chromosomes when the genome was being put together. And I think the idea of structure and structural variation grew out of that original thinking. But cytogeneticists like Alka and other cancer biologists, people doing research and work and medical treatment in genetic diseases, hematologic malignancies, solid tumors, have been using the tools of cytogenetics for years and years and years to look for these chromosomal rearrangements. So it's not something new. The reason it feels new is that for the first time, and I think Bionano has been at the forefront of making that happen, but tools have been evolving to make it much more accessible to analyze genome structure. And so this is why we think cytogenomics and cytogenetics is reaching into its utopia phase here, because they can become a part of big biology. When it was just karyotyping, fish, microarrays, gel electrophoresis to analyze genome structure, nobody wanted to use those in big clinical trials. But now that the Sapphire system makes that accessible the way it does, the way that other systems are approaching genome structure, now the structure analysis of the genome can be just as important as the sequence analysis.
Alka, the last time I talked to you, you were doing testing in the lab. Isn't that what you're supposed to be doing?
Absolutely. This is what I'm supposed to be doing, and this is what I will be doing.
Okay. So tell us about why you came to work at the instrument company and what you are doing.
So when we spoke last time, Carol, I was the director of the cytogenetics laboratory at BNGO Genetics Center. Mm-hmm. And so everything that Erik has just spoken about, one thing is that structural variations are not new, because structural variations have been analyzed or have been interrogated as a part of the genome since the 1970s. However, the issue was that there is a limitation with every technology that was adopted in the clinic for diagnosis and detection. So structural variations have been around for a very long time. So let me just, add that, in clinical diagnostics. But from there, between then and now, I also, was at another company as the head of cytogenomics, where the focus was to try to use sequencing technologies to interrogate all classes of variations that happen in the genome. So whether it is structural variations or whether it is sequencing variations. So we realized pretty quickly that there are a number of disorders and a huge part of the genome that cannot be accurately interrogated by short-read sequencing. So as part of that, people still need to diagnose and to find the genetic causes of a number of genetic disorders, whether it is cancer, whether it is children with disabilities. And this is where optical genome mapping comes in. So if you remember last time, as from the other side, as a laboratory director, I had been waiting, like my colleagues and peers, for a technology that can be the next generation cytogenomic tool that has higher resolution, that can provide more answers, and can be adopted in the clinic by laboratories that usually adopt newer technologies. So this was the impetus for me joining Bionano to drive this in the form that it can become a valid clinical tool just because of the power and potential that optical genome mapping has.
Okay. So Erik, and by the way, please either of you jump in here.
Well, I was gonna say that there's another answer to what Alka just said, which is that she grew frustrated by our attempts to do what she described, so she decided to come and push us and really make it happen. And
okay,
there's no question that she's doing that.
So talk about that frustration and what she wanted to push for.
You're putting me in this situation, okay? So,
well, I'm curious to hear what you want to say, and I'm curious to hear what Erik wants to say about that.
So again, coming from the laboratory side, if you look at majority of the tests that that are used in clinical diagnostics, right, by certified directors, by laboratories to offer to the geneticist or physicians or pathologists for no matter which genetic disorder you choose, there are so many things that we need to put into place, regarding the specimen type, what kind of assay structure should it be, what should be the throughput that a laboratory would want, the ease of adoption, the reproducibility, the fidelity of the assay, and the ability to interpret those variations coming out of any technology appropriately. So Bionano, as you just started this conversation with the funding and everything, had been moving obviously, but now we have the leverage to really add a lot of fuel to these efforts to make progress in so many different domains that we can cater to what the customers would want in terms of adoption. So I think this is what Erik was referring to.
Okay. So Erik, talk about some of those domains.
Sure. I think that when we think about a platform like the Sapphire system for genome analysis, and remember, this is what we're doing here is optical genome mapping, which is also an idea. David Schwartz was really the one who was coining that name, and there have been other companies that have gone down this road, and our technology, which is really at its core nanochannel arrays, enables the massively parallel linearization of DNA molecules. And then we use single molecule imaging technology. The optics industry is just improving every year and making it faster and faster and faster, easier and easier and easier to see these images. And so now we have these arrays of massively parallelized, linearized molecules. We label them, they have patterns on them like barcodes from the genome. We take a picture and we know where every one of those fits. And so this technology has incredible utility. The question is, where is it going to be adopted first? And what we're actually seeing now, that we have finally reached I think a critical mass in like weekly or yearly throughput. So around 96 samples per week, upwards of 5,000 samples, human genomes per year can be analyzed on the Sapphire system. This is sufficient to accommodate many large research studies, translational research studies, but laboratories can adopt the system, research use only, develop an assay and validate it as a laboratory developed test, and then use it in patient testing. The question is, how would they use it? So they would be following medical guidelines, right? Today, they're following medical guidelines and using microarrays as frontline in genetic testing or karyotyping in cancer. And so the Sapphire system can actually be used as an alternative to those modalities. So it can do everything karyotyping can do and more, everything that chromosomal microarrays can do and more, and FISH as well, with the exception of some rapid FISH assays. So there are some FISH assays that are very fast. So this becomes a compelling capability that labs can adopt. Where are they going to adopt it? Guess what? In Europe, they're adopting it very, very broadly with a focus on replacing these traditional cytogenetic assays. And so we observed this, we saw this, and we wanted to follow the same path here in the US. But what we learned is that a lab that's running a workflow and getting reimbursed for it is not always super enthusiastic about changing that workflow when the reimbursement is somewhat ambiguous. And so this is an area where we are uniquely investing, and Alka is leading an effort around a number of clinical trials to develop the data sets in 4 areas: prenatal, postnatal constitutional genetic disorders, hematologic malignancies, so leukemias and lymphomas, and then solid tumors. And so within those 4 areas, we're building an incredible data set of analytical validity. The clinical validity and clinical utility of these biomarkers are already established. We don't need to prove that. They're being tested for every single day.
Right.
But we need to prove that the system works like those other capabilities do, illustrate that benefit to payers, and we expect to see reimbursement increase here in the US. And so then the US can start to catch up with Europe and other single payer healthcare system countries for the adoption of this technology. And what we believe actually, and we've seen so much adoption and use in research, different discovery programs over the years. But what we really believe is actually once the technology is broadly available as an LDT, for example, in labs that have developed the assay and offer it, the research use will pick up, because then if you discover something using Saphyr, there will be diagnostic testing that can be
it will lead to the
so those things go together, and that's where the big biology comes from.
Okay, so Alka, have there been LDTs already created?
Absolutely. And prior to my joining Bionano, I actually did validate optical genome mapping for a very unique muscular dystrophy disorder that is very difficult to diagnose, and a number of very cumbersome technologies are needed just because that part of the genome is refractory to the conventional methods and even to sequencing methods. So this is where, as Erik mentioned, that these long linear molecules come into play, and they have such a huge utility to pick up these large structural variations. So I'll tell you like a little bit of a personal thing that almost 5-6 years ago, when I first saw optical genome mapping and these DNA molecules shooting through the nanochannels, it was one of the most beautiful technologies that I had seen. And this was, at the time when I was still at Greenwood Genetics Center. But this is something that we needed to develop and bring it to this point that these clinical applications can be adopted. Now, keep in mind that if you look at the whole continuum of care, if you start with prenatal diagnosis, right, to try to pick up aneuploidies or other microdeletions in fetuses, right now for prenatal testing, if we move on from there to postnatal, now babies are born, they may have a congenital anomaly, they may have a birth defect, they may have delays and autism, as they're growing. Then we come to leukemias and lymphomas, mostly, that happen in adult onset situation. The whole continuum of care, structural variation detection is the standard of care. And now we have this high resolution technology that can pick up so many things that fall in the limitations of these conventional methods. So there are a number of labs that have adopted and brought on or even a whole genome application. So we have a laboratory that has adopted optical genome mapping in conjunction with whole genome sequencing to have a complete genome test. And then there are other laboratories that have adopted for unique clinical applications. So you can just see that slowly we have made that headway, and now we need to make sure that we can develop more applications.
Okay. So you talk cytogenetics here, Erik. In the opening plenary at the conference, we heard some amazing examples from Catherine Brownstein of Harvard Medical School and Boston Children. So that's an example of research and actual applications. She had an example of the neurodegenerative disease. Let's drill down some more. What are some other examples? Who are some of your biggest fans?
We have worked with different labs in a number of different areas over the years. And, I think that, you mentioned neurodegenerative disorders with Mark Ebert, who has been at Mayo in Jacksonville, Florida, and is on the move actually to the University of Kentucky. But he's worked in different neurodegenerative disorders, looking at very complex rearrangements that are so complex that they simply couldn't be resolved by any other method than optical genome mapping because of the structural accuracy. And by resolving those complex structures, it then drives hypotheses in the biology, such as ALS or Alzheimer's disease. And the thinking there is that the degree to which these structures and their variations start to appear more and more consistently, then you have a biomarker that you can follow and use for testing. There have been many other areas in cancer or pre-cancer, such as myelodysplastic syndrome, MD Anderson. They have a Sapphire system, and what they've been working on is looking at patients who would be coming in for a classical diagnosis, but mapping their genomes, and what they find, and this is published now, that they see all the markers that the traditional methods see, but then they see a whole host of others. Why is that important? Well, something that we know in hematologic malignancies is this idea that if you look at the Kaplan-Meier curves, it's really a tale of two cities. You have split survival. You have some patients who you have good outcomes and relatively long survival curves, and other patients who have poor outcomes, short survival curves. And yet, at the very start of treatment, their molecular profiles were identical. And so by being able to pick up these additional markers, and they've done this at MD Anderson, but also at Penn State, it provides a higher level of resolution or degree of refinement as to the prognosis for that patient, and can begin to, instead of having split survival, two populations, but now give you the whole spectrum. And this is just clearly important in discovering the drivers and mechanisms of cancer and cancer biology, but then manifesting or translating, as Erik Green would say, translating into an application that has clinical utility. And one thing I want to mention about the technique or the technology, this idea of optical genome mapping, starting as something that looks at single molecules. So when we look at 500,000 cells, and all those copies of the genome in single molecule fragments, we can look at them multiple times, and it's possible to distinguish populations within a sample, right? So this is mosaicism in genetic disorders, but we all know that in a solid tumor or even a liquid tumor, the pathogenic cell type may be present in very low abundance. And so the Sapphire system is capable of very straightforwardly getting down to as low as 1%, what we call allele fraction. And that's well below the typical limits of a clinical test. So a clinical test is 10 or 20%. But in research, you want to be able to find that one cell, out of 100 that could be responsible for the phenotype that's being observed. And the Sapphire system can do this very straightforwardly, rapidly, and at low cost. So it really positions it to be a powerful tool for discovery. Those are a couple of really interesting examples that we've seen and that are being described, presented, and published.
Alka, do you want to pick up on that and talk to the research discoverers in the audience? Talk about it as a discovery tool, the limitations of sequencing, and what this can open up.
So I think when you mentioned Catherine Brownstein, so I'll just take it on from where Erik ended. One of the things that she's also part of is the COVID-19 Host Genome Structural Variant Consortium. And that consortium is led by Dr. Ravi Kolhe from Augusta University, and it is an international consortium. We have 70, 80 collaborators there. And using the Sapphire technology, what the main initiative is, because we are in the COVID-19 pandemic, so this definitely requires a little bit of a mention, is to look at the human genome and see what these structural variants are, because we know that the diversity in humans is also largely due to the structural variations in the human genome. So what could be at play, and what could be the predisposing factors, genetic factors, that allow people to have different effects when exposed to the SARS-CoV-2 virus? Why do some of them end up in the ICU and die, and why some of them end up in the ICU and recover, and why some of them get infected but still remain asymptomatic? So that is the premise, and she touched a little bit upon how they are trying to collaborate, and also looking at children that develop some multi-inflammatory systemic features after SARS-CoV-2 infection. So there's a collaborative effort going on to try and resolve the unique variants versus the common variants, and to tease out this pathway, because there are so many other human genome initiatives that have started in 2020, right after this COVID-19 pandemic. So when you look at that, the amount of literature and information from last year alone on COVID-19 is absolutely phenomenal, right? It has just been exponential. But if you look at what are the variants that have been actually identified, what is the yield of testing hundreds and thousands of individuals, and also sequencing the SARS-CoV-2 genome along with the host genome, if you look at the sequencing yield or the sequencing output, in literature, it's really not a lot. That means there is a lot more that is hidden in the human genome that people have not interrogated. So this is just one example of that initiative. The other thing that I just to add on to what Erik was saying is, I'm just going to cite one example in leukemias and lymphomas or hematological malignancies. One, there are two ways that the tumors start progressing when you look at one class of structural variation. So either there will be a fusion protein, which is oncogenic in nature, which one example is the BCR-ABL fusion, right? It's a fusion protein, oncogenic, and we know we have the wonder drug Gleevec for it. But there are some fusions that happen because of a translocation that bring in a proto-oncogene in the vicinity of a constitutively expressed gene. So one of those, for example, is the IGH translocations, which are very common. It's the immunoglobulin heavy gene, very well reported in all types of leukemias and lymphomas. And there are almost 40 translocation partners or more than that are reported. So it's very difficult for a laboratory that is working on hematological malignancies to try and tease out what is that translocation partner. Now, sequencing, just because of the polymorphism and the cluster and the number of these immunoglobulin genes, cannot pick up any of these translocations or any of these SVs. So this is where optical genome mapping, just because of the long molecules and because of the labels over there and the accuracy to be able to show those translocation partners, and all of this now is being published by multiple people, both in US and Europe and rest of the world. And this kind of showcases the utility of optical genome mapping in certain classes and certain unique applications.
Yeah, okay. Do you want to follow up on that, Erik?
Well, I'm sort of, inspired to think of one thing, and I don't think it's controversial, but in working with Alka and Ravi, with the consortium that they have put together and observing the growth, and then subsequently reading things like their NIH grant and the manuscripts that they put out, there is a belief amongst these scientists and clinicians that genome structure and variation of genome structure, genome structure and variation of genome structure is very likely to be as important, that's the sort of political way of saying it, and maybe even more important than sequence variation. And so why is that? Of course, I think that because we're the structural variation company. That's what it says there. We love structural variation. We don't focus on sequence variants. And there's a reason for that, because if you want to get to single base resolution, you have to slow the system down. So we made a conscious decision to say, well, we're not going to do single base resolution because we want to go fast. Right. It's got to be relevant for large studies, clinical use, and clinical applications of LDTs is what I mean to say. It's got to go fast. So we'll sacrifice the single base resolution. But the other thinking is that large rearrangements in the genome can impact many genes, many other functional elements in a single swath. So, like a tornado is a really big deal, and when it goes through a town, it's pretty mangled often afterwards. But a heavy windstorm doesn't often produce that effect. And so structural variation, the hypothesis is that it's driving a lot of biology. The technical challenge is that because of the repetitiveness of the human genome, it's not just the human genome, plant genomes are even more repetitive than the human genome. The human genome is the one that gets all the funding, good. But it's so repetitive that resolving the repetition is required to see its structure. And so, I believe that the work that they're doing in this consortium around COVID and, how patients respond to the disease and progress, these other areas of, we talked about neurodegenerative disorders, cancer, the amount of biology that's laying there, that's been invisible. It used to be called the dark matter. Right. It's huge. It's big. It's substantially, substantially large. Maybe larger. That's not for me to say. That's for us to figure out.
Well, I appreciate you going into that. I mean, if somebody's going to know, you should have a kind of sense of that, right? With your customer base. And I understand that, it's kind of an intuitive sense here. You use the word, I believe, because we're just nibbling at the edges, maybe. Do you have a sense of where we are in big biology? I mean, are we just at the beginning? Are we kind of in the middle? Are you getting a sense of that?
Yeah, I mean, we have thought about it in the following way. And so that is, when we looked at the first 2 decades of this century, I think clearly the 2000s were the microarray, gene expression, SNPs, and next generation sequencing came in, revolutionized Sanger sequencing, and brought genome analysis, especially DNA analysis, to an incredible level, industrialized it, right? Really made it something that could go affordably and fast, so you could get populations done. And to a certain degree, that has leveled off. If we look at the outcomes, though, they're extraordinary. So, I was in molecular diagnostics right out of school, and I observed Randy Scott and Genomic Health. And when we think about what Genomic Health did to create molecular diagnostics, deal with the reimbursement and all of those things, incredible, but enabled by microarrays and other genomics technologies.
So they were incredible. It had to be the first and the first and the first and the first. Yeah,
the first is tough, but amazing. And now when we look across that industry, we see a diaspora of companies that grew out of that idea. And for those people who pay attention to the stock market, are very handsomely valued right now. So that whole industry came out of those first 2 decades. But look at adaptive biotechnologies and sequencing all of the T-cell receptors. This is something that NGS and genomics has driven. So but I do believe it's fair to say that now the focus is much more on content and applications of the technology. Those technologies are not as advancing at as fast a rate. Illumina has acquired Grail. They have an intense focus on content and applications. So So big biology is going to come somewhere else. We know about spatial biology. It's incredible. Single cell biology. But within the genome, within the nucleus of the cell, structural variation is it. So we feel we're very much at the beginning of the movie. We think it's going to be an incredible movie. And we're excited to be at the forefront in helping it unfold. But we're very much at the beginning. And that creates a unique challenge for scientists who want to work in this space, because when you do sequencing and you do resequencing and you find single nucleotide variants, there is an abundance of databases out there for which you can look for that variant and see if somebody else has seen it and described in the literature. There has been no tool that allows that systematic discovery and cataloging of structural variations. One of the most important steps in that process was taken last week by Charles Lee, Jan Corbell, Evan Eichler, who are the co-chairs of the 1,000 Genomes Consortium, which has been focusing on structural variation for over a decade.
And
they published
a major character in this movie.
Big players, and they published an incredible paper. Bionano was part of it. Long read sequencing was a part of it. Illumina sequencing was a part of it. And the most complete collection of genome variants ever, spanning ethnicities. And this is the starting point. There's some 100,000 or so variants in there. And so this is really the start of having the information to begin to rationalize that N+1 discovery. And so when we build that infrastructure for discovery, which is ongoing, those guys have done it, but there are other consortia working at this. Ravi's consortia is looking in a narrow field, but pretty topical: COVID susceptibility and COVID response, host genome response. We'll build these databases, and that will enable this wave to build and build and build. And it seems like an incredible opportunity for discovery, and it seems like it has to be the area of big biology. And one thing that's unique about it when you compare it back to the first 20 years of the century, okay, is that this, the era of structural variation is coming off a foundation of structural variation driving so much clinical practice already today. SNPs were not such a big deal. We're not such a big part of mainstream medicine. But today, if you have a genetic disease, you're getting chromosome microarrays. If you have cancer, you're going to be karyotyped. And so now these technologies will build on that foundation. So
that's true. There are some tracks that have already been laid, right? There are a lot of tracks.
Absolutely.
Absolutely.
So Alka, we're over halfway. You're very passionate on this topic. This is AGBT. Have you said what you want to say? Erik said the movie has yet to play out. How do you see the movie?
I completely agree with Erik. And one of the reasons is, as I mentioned, karyotyping and has been in use since when? Like 1970s. The reason why it's been there, right? And then FISH evolved and standards and guidelines came in. Remember, there is no FDA approved or cleared for karyotyping or FISH. I mean, those assays are all LDTs that have been used since 1980s and 90s, right? For the most part, there are a few FISH ones for some applications, but the majority of them. And then came microarrays in 2010 that were adopted by medical associations such as American College of Medical Genetics, American Academy of Pediatrics, American Academy of Neurology. And those set the pace for what should geneticists, pediatricians, neurologists, pathologists, what should they do when they are faced in a situation when a patient shows up with specific clinical indications, and what testing should they follow for patient management and care. So this is what I have learned all along, and this is what I have been part of. And I've seen the evolution of, Sanger sequencing being used for single gene disorders or sequencing variants, and then moving on to next generation sequencing, again, around 2010 and so, and then exomes and now genomes. And every time a technology came in, it was like, well, we're going to take care of structural variations too, and these technologies may not exist or will be obliterated. But guess what? Cytogeneticists have evolved into cytogenomicists, which is what we call as a next generation cytogenomic revolution. However, we realize that all of these emerging technologies that are becoming the standard of care, if we look at even prenatal diagnostics, right? So the International Society of Ultrasound and Obstetrics and Gynecology or American College of Obstetrics and Gynecology, all of them have recommendations and guidelines for confirmatory diagnostic testing. And all of them cater to the detection of structural variations. So now if we look from 1970 to 2021, where we are, what is this era and what are we going to see now? We are going to see all of those hidden parts of the genome. We are going to be able to identify in terms of discovery and diagnosis. And I also believe that this is just the beginning of how structural variations and, optical genome mapping can be used as a tool for patient care and management. That is what we are here to do, right? For genetic testing, for betterment in terms of diagnosis, so that physicians, pathologists, oncologists can better manage their patients. So this is the reason why I've joined Bionano Genomics.
Okay, so what's the path to actually get a test reimbursed? Like, how far away from that are you guys? And what do you have to do to get there?
Well, some of the laboratory developed tests that are running on Saphyr today are reimbursed today because they're looking for analytes for which there are existing CPT codes that are analyte specific. Other CPT codes are more technology specific, and so they apply to a specific legacy or incumbent technology, and maybe not so obviously apply to the Saphyr system. And so for those types of LDTs, and a good example is just genome-wide structural variation for a genetic disorder analysis. So the comparison would be chromosomal microarray. That process involves getting the data, doing the analytical validation, and we have some of that. There are a handful of papers have been published, and we're going to drive more and more of those papers. And so getting the analytical validation, people appreciate it when I make claims about the capabilities of our technology, but they appreciate it more when we prove it in a publication. So we need to do that, and it's not just one paper, it's multiple papers, and it's also papers here that are coming from US-based institutions, because there are idiosyncrasies associated with those genomes and those samples and those programs. So a data set, and we're working on that. But it's not just a data set, it's really working with other labs or having other labs see the need for and utility for the capability, setting it up, developing LDTs, applying for their own reimbursement codes, proprietary laboratory analysis codes, and then testing patients and sending the bills to insurance companies. Because when that happens, it's analogous to what happens in the research side of things. The first person who sends a grant to the NIH hears that nobody's at the NIH has ever heard of that. Can't be any good. But when they're, which is why I left academics, but I'm saying, God bless all these AGBT folks who are
Erik wasn't
fighting it out. I was. So if there is a critical mass of adoption in the field, then it starts to make sense for payers to pay more universally.
Right.
So that's the path that we're on. Right. And that the market is on.
Yeah, you mentioned Genomic Health. They were a lab who got reimbursement for their tests, but of course they weren't an instrument manufacturer. They were using other instruments, right? So it'll be a lab like Greenwood Genetics Center, which will get using your instrument, which will get the test reimbursed, right?
Right.
Yeah.
So,
and the distinction, I would say, the distinction is pretty important, right? Because Genomic Health, looking at certain patients within, breast cancer stage 2, looking at a set of biomarkers, which based on a panel that they have curated, and looking at patient outcomes and working very hard to determine what is the right way of applying that information, adjuvant chemotherapy or not, and how does that improve outcomes in the long run. So establishing this idea of clinical validity and clinical utility. We don't contend with that, because the tests that our end users run on the Sapphire when they develop an LDT are the tests that they are running on karyotyping, right? So the clinical validity and utility is already established, and that is not something that needs to be argued about. What needs to be established is that the performance is comparable to those existing methods or better, and that there's a compelling reason to switch. And so that's what we focus our efforts on.
So Alka, you mentioned that you joined the company to kind of push them along for certain things. Do you want to talk about that, like what you'd like to see happen in the next year or two, and also what you're hearing from labs like you used to work in, and even around the world?
Absolutely. So as I mentioned, right, this optical genome mapping is a very unique technology, right? That it fills the void in so many places. Just one technology that can even enter the prenatal clinical application space to postnatal, to leukemias, lymphomas, and solid tumors. If you just look at, as I was mentioning earlier, the continuum of care, it just is an ideal technology. But there's more work to be done, absolutely, because every lab that wants a platform wants it to be cost effective, wants it to be ease of adoption, wants to be able to do the analysis and interpretation in a manner that that is understandable, right? A lot of the genome or genomics or information that comes out, a lot of algorithms need to put into place before you can make sense of all of that information. What we are trying to do here is to provide these variants in a manner that the labs can understand it, relate to it, and can immediately understand the clinical interpretation or application of it. Now, in terms of what we are trying to do here, what I would like to see in the next, in this year and the next year is exactly what Erik was alluding to. We are going to be promoting and doing a number of clinical studies with a number of our partners and early adopters of our technology so that they can develop all of these applications. And now we will be directly working with them so that we hear their voice. What do they want in their lab so that we can help them do their job better? And no matter which way we look at it, do we need to develop more sample type applications? Do we need to, how much more throughput do we need to increase? Do we need to reduce the turnaround time? What would be the most cost-effective way that they get all of this high resolution genomic information and it is affordable for them? And along with that, allow them to make sense of all of this data that they have never seen before, but they can look at, relate to, and say, I get it. I know what the structural variation means. I know I can see this translocation. I don't need 20 years of experience to sit on a microscope to look at a metaphase and say, I don't know what this is, and I've not been trained on it. But to look at optical genome mapping data on the screen, and it just tells you exactly what's going on in the genome, is something that, I think that is how we'll be able to help all of our customers. So this is what I would like to see this year. There's multiple applications by multiple laboratories, and just to, move forward in that direction.
So Erik, let's end and look forward with you. Our last question, we were talking about reimbursement, made me think the other tools company, the sequencing tools companies are becoming diagnostics companies. Actually, they are seeking FDA approvals and Illumina, you just talked about Illumina buying Grail. I mean, Illumina's turned into a diagnostics company. I'm curious, for you to look out long-term at your future, but also short-term, how are you going to spend that $400 million? I'm sure you have customers in the audience. What can they expect over the next year as well?
Sure. So, I think that our focus on performance of optical genome mapping in the Saphyr system is really kind of everything for us, and that's been kind of proven over the years. The faster we make the system, the easier it is to use, the more affordable it is, the more people there are out there who are able to adopt it and want to adopt it. So it's continuing to focus on that. So a dimension that Alka brings is this ability to do these types of studies outside, bring third-party unbiased data into the picture. And so now we have product improvement going along with sort of product development and product improvement going on with market development to define the applications, connect the dots for end users of where and how to use the technology. So it's really a really good alignment of the outside and the inside of what we can do. To be very specific, we want to continue to increase the throughput of the system, and so we've talked about this. We achieved a level of about 5,000 human genomes per year. When you do cancer, you go really deep in the genome, those numbers go down a little bit, and so we just want to keep doubling down on that. That was a 14-fold improvement from the time that we launched the Saphyr system at AGBT. Lisa, I saw you earlier coming on, so thank you for the venue, as always, to be able to showcase the capabilities. But we launched that at AGBT, 364 human genomes per year, which was something that was incredible. It's now up to 5,000, 14-fold improvement. And so we're sort of going for another 14-fold. Now that's going to take place over a period of years, but we will focus on that. And so people who are adopting technology today will enjoy additional improvements based on software and other capabilities that we bring in. Cost is something that we're very focused on, and so we want to continue to improve our own manufacturing methods so that the cost of manufacturing the product can go down continuously. It has been, but it will continue to go down. And we sort of get it. Like, we're not going to keep all those savings for ourselves. We're going to pass them on to the market, because we see that when these assays get more and more affordable, there's more and more adoption. So those are things that we're focusing on. So I hope people don't hear this and wait to buy the system or buy the product because, oh, we'll wait till it gets cheaper. Don't do that. Start working now, and then when the prices go down, your volume can go up. You can do 2 times more patients and so forth in your study. So those are some really important, I think, blocking and tackling initiatives along with the studies that Alka is going for. But we raised I don't know how else to call it. I mean, it's a ton of cash. We've always been capital starved. This has been a limitation of Bionano Genomics from the time that I joined. I have been the CEO for over 10 years now. I joined in January of 2011, and I didn't have any gray hairs when I joined.
Okay, so that
wife said to me the other day, and my wife the other day says, I only have gray hairs now. So, there's the natural progression, but we view it as having another decade to work on this, and that it's our calling. It's our calling to drive this forward. And so, are we going to become more of a diagnostics company? Guess what? In August of last year, we acquired a CLIA business focused on pediatric neurodevelopmental disorders. So we are selling services. It's called Lineagen. So through that business, we sell services. We have salespeople who call on pediatric neurodevelopmental specialists and pediatric genetics specialists every single day. We have tens of samples coming in the door, hundreds of samples per month of kids who are trying, and their families who are trying to figure out what is driving their biology by looking at their their genome. And the reason that we did that, and maybe this is what you were talking about, is that if you want to be good at providing solutions that help diagnosing patients, you got to know something about diagnosing patients. If you want payers to pay for tests that your customers are going to be buying from you and utilizing, you got to be talking to payers. And so through the acquisition of Lineagen, which is an incredible team based in Salt Lake City and around the country, and the sales side, we have a whole host of contracts with payers. And so we're interacting with them multiple times per day, right? It's part of our business. We're interacting with patients. We have genetic counselors. We're explaining to families what their chromosomal microarray and whole exome sequencing results mean. So we have that. And so when I think about that in the future, what I think about is when we integrate Saphyr into that business, and now you have Saphyr surrounded by whole genome sequencing, whole exome sequencing, and all of these tools. I actually don't know exactly what that's going to produce. I just know it's going to be amazing. The capabilities will be amazing. And by being fundamentally a life sciences instrumentation company, our goal is to proliferate the technology, and so we're going to figure these things out. And as you can see, we're talkative. We're going to tell everybody about it. Right? So our goal is to figure stuff out and then teach people how to leverage those tools and those capabilities. That gives us a ton of joy. That gives us a ton of motivation. We know it's all directed at helping people. And so that's why we look at the next decade and say, for us, it's the decade of Bionano, but it's the decade of structural variation analysis.
Well, it's really fun to share your passion for this. And I look forward to hearing more about that, seeing that in the future. Erik, Alka, this has been a real pleasure. Thank you.
Thank you very much.
Thank you, Daryl.
And thanks to the folks at AGBT and LabRoots for making this a successful presentation. Thank you, everyone.
Thank you.
And that's...
Thank you. Thank you. Oh, goodness gracious. What's going on here? Welcome, everybody. Oh, we back, baby. What's going on? Oh, my goodness. How did you guys find it? How was it, baby? There's been thousands of comments. Thousands of comments. I just want to thank everybody for tuning in, man. And yeah, you guys made this happen. You guys, all the donations you guys sent me and supporting my channel, you guys made this happen. So whatever future events are going on as well, I'm going to try and get us into them. So just take a look at BNGO's events, and whatever one's popping up there, I'm going to try and get in. But yeah, baby, I wanted some more Alka as well. I wanted to drop some more fire. We wanted to see that. You're right, Kevin. We wanted to see more sales figures. We want to see some numbers, baby. But the numbers will be coming out soon in the earnings, won't they? But yeah, good to see you all here. Thank you guys for sharing my link on Stockwits and Twitter as well, man. Amazing. Oh, baby, I'm just seeing loads of messages. Thank you all. Oh, no, no dinner. No dinner, baby. Oh, my goodness. Thank you guys for tuning in. So, yeah, what's the next event we got coming up? I don't think we're going to be able to get into the Oppenheimer one, but we'll see. If anybody knows any institutional investors or somebody who will be going to that conference, let me know, and I'll have a little email with them. Get a little bit of an email. Get in there. You're a legend, man. I love you guys. Thank you, guys. Earnings call March 6th? Is it a March the 6th? Oh, baby. I tell you what, I spent all my money on Workhorse and Occidental Petroleum when I first started investing. I went so heavy into those stocks. It was aggressive. Mr. Investor Lot is just, I don't have a lot of money, but I invest aggressively. So yeah, after I got some new cash flow, that's what I spent on BNGO and some other stocks. There's so many comments here, baby. Oh God, yes. You know what? Do you know the NP form? This is a question I have for you guys. The NP on the form on Fintel, what does that specifically mean? Because we know that the other form is like a 45-day delay, right? Is it the same with the NP form? So does that mean that Vanguard bought those shares 45 days ago up to the last quarter? Oh, baby. We love it, man. We love it, baby. Mr. Invest a lot, baby. I'm hopeful. You know what? I'm hopeful for this one, but I'm looking forward to the ones after as well. I'm still compiling a video together for all of the ways I think that we're going to be able to earn money. But yeah, I would love your input as well. Whatever you think are going to be our revenue streams in the future, just hit me up in an email. Just drop it to me and I'll include it in the video. But yeah. Oh man, yeehaw. I see you, baby. I'm not sure when the exact earnings report is, but the algorithm was saying it might be like March 19th or 14th or something like that. On different websites. Some people are just guessing. We literally have no idea. I don't think there's any official one yet. So yeah. Thank you guys. Thank you guys. Yeah, man. I appreciate it, man. Thank you for all the donations, by the way. Everybody that sent donations, you know, it just helps me and my brother create more content. That's all we want to do, is just bring you the best content we can. Yeah. 1 second, let me check for you. Dun, 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 dun. I bought BNGO when it was at $2, and then I sold it when it was at $4.80. And then when I learned more about the company, I actually ended up averaging. I actually bought some more and actually averaged up. So my dollar cost average price. Let's see what we're currently holding. Yeah, remember, guys, I'm not a rich guy. Although you guys may think I'm like living in a mansion and that, Mr. Investor is just aggressive with the money whenever I get it. But right now, my average price is actually $11.92, and I'm holding 72 shares. But man, I would love to average down. If I had some more cash now coming in from YouTube, I'll average down, baby. Greetings from Malaysia. Thank you very much. Greetings, baby. Thank you all for joining me, man. Shout out to the Full Bull. The Full Bull podcast. Come on. Shout out, baby. I would love to. I would love to. As long as they make it clear and I'm available. I'm available on the day, baby. I'm gonna make sure I throw that in there. Thank you very much, bro. You know what? When I was there, I was in AGBT, and when I was inside, I was looking to see what's going on and what people were discussing. So everyone was promoting their company, and then there was one body, I can't remember what her name was. She was from one institute or body, and they were basically exploring. They were exploring the European genome the most, but they were saying there's so much data missing, and it's different. It's so different. So I think there's going to be a lot of exploration on the other continents, which is what I'm really bullish about. And there's so much funding going into it all across the world. But yeah, what is Meet Me? I don't know what Meet Me is. So yeah, just tell me what it's about, bro. Investing streams. Ooh, baby. Oh man, I would love that. I would. If I had that, I would. Straight in there. I like what's his name, Keenan Grace, when he's like, yeah, get $100 in a and you may never see this price in a Love that guy. Love that guy. You know what? Oh baby, I just keep watching it. It's just like a juicy sitcom watching Simon talk to like different BNGO investors and also Joe Butler. I love seeing their conversations, man. I'm just there like eating popcorn, enjoying it, baby. Super bullish. Come on, Paul. Thank you very much, Jared. Miguel, you're becoming our go-to source for BNGO news, especially with your live presentation coverage. No one else is doing this. Thank you for your work. Oh, man, I appreciate you all, man. Baby. Thank you so much, guys. I really appreciate you guys being here. OGM, only going to Mars, baby. Thank you. Guys, you can donate anyhow. I've got different donations there. You can donate through PayPal. You can donate through YouTube, or you can sign up to Patreon. What else? You can even sign up to channel memberships. But yeah, I appreciate any donations, man. It's just going to help us create more content and all those other festivals as well is what I'm planning to get into. Oh baby, I see you guys here. Oh my God, is that a yeehaw? There's TMG in the house, baby. They're an ultimate cowboy. I'm gonna be buying you guys dinner when I see you guys. Woo! We're gonna be eating in London, baby. I really want to get into this. If I can get into this, oh my God. Shawnee boy. Sean, I just seen this. Thank you so much, brother. Thank you, man. Thank you, my brother. I appreciate you guys, man. Thank you. I just want to bring you value and entertainment as much as I can. So yeah, it's exciting. All these messages are popping up everywhere. I'm just like, oh God, everybody messaging, baby. At the current price, I wish I had more money. I'll just keep buying because obviously my average is $11.90. So I believe in the company long term. That's just what I believe in. I can see so much money going into the genomic space. I think we still have a chunk of the industry that we can fulfill. Thank you, Fabian. Oh my God. Thank you, George. Thank you, brother. We need a bingo community on Telegram. I've never used Telegram before, bro. Are you going to do a music video shoot soon or find bad guys who tried to kick your dog? Yeehaw! You don't kick my bingo, baby. Oh, baby. I think they can. I think they can coexist synergistically with both Illumina and PacBio. I think he believes, based on his research, that PacB is going to take most of the market in genomics. That's what he's bullish on, isn't it? Long reads and that. But yeah, I think we can still get a chunk of the market, a little slice, and make some money, baby. And it all depends on what we're going to do in the future as well. And I think people also forgetting, when I was in the Festival of Genomics, we were talking about, a lot of people were talking about the consumer demand growing to explore your own genetics. So you see the genetics testing with Lineagen. A lot of people are doing that for neurodevelopmental disease, right, or disorders. But yeah, if we're able to do that across the board for all these other diseases as well, say we can map like diabetes as well in the future, or all these other kind of comorbidities, and people are curious about it. Can you imagine how much money we can make there? So I'm just thinking that's why I've got a little bit of a nice slice of VGAC as well that I currently own. Baby, I think the earnings are going to be decent, but I think the best earnings are going to come a few quarters down the line, because if we look at the dates, like Symposium was a massive one for Bingo. I think we will start to see some really juicy sales maybe later on in the year. So yeah, on the next quarters, I'm very excited. This first quarter is, yeah, it's going to be all right. But I think with all of these events that have come up, the quarters later on in the year are going to be the ones that bang. Oh, baby. Oh, baby. Is that what WSB are doing, yeah? Yeah, I'll definitely want to do that so we can all communicate. It'll be really nice to have a Discord group. Bank me instead. Oh my God, put him in a coffin, he said. Look, oh my goodness. My goodness. Oh, baby. Thank you very much, Crypto. This guy gave me my first Bitcoin, man. I'm a Bitcoin noob, and this guy sent it to me. Thank you so much, brother. Appreciate you, man. Yeehaw, baby. Whoa. Yeah, I want to join. I heard there's a Discord group already for Bionano Genomics, man. Oh my God, Messenger, you're so naughty. You so naughty. Maybe he's been a bit cheeky. I heard who said this? I think I was listening to Bobby. Bobby sent me this. They were basically saying that 23andMe might have some old tech. So could we actually help them out? Lease out our machines to them? I don't know, baby. Are there even any legit arguments from competitors against using Sapphire? No, there's just some researchers. Some researchers have sent me a bull. They've showed me bull angles and a bear angle as well. So I've got to get through it. They sent me like a 6-page document, and It's a really good read. It's just so dense and heavy for me to understand. So I've read it like 3 or 4 times, and I'm going to keep going through the argument to see why they're not so bullish on Sapphire and why they are bullish on Sapphire. Oh, baby. Oh, can I pay PayPal 500 shares to you, baby? If you could pay in shares, I love shares, baby. I don't know how we can do that, but baby, I would appreciate it. The Google of genomics. Oh, somebody said Tesla. Somebody said Google. Oh my goodness. Oh my goodness, baby. Simon is crying right now. You know what? After I saw the comment where he's like, yeah, I've learned a lot. I think, you know, you have to constantly study because the tech that we're bringing out. Woo! Thank you, guys. Oh, hey, Bobby's in here. Bobby, MVMD. I remember the DD this guy done on it. Thank you, baby. Ooh. I'm putting long-term price targets. When you see that on my thumbnail, it's because that's what I believe it's going to be long-term. We still don't know when the earnings are coming. We don't know yet, baby. But yeah, I'll be on it. If they live stream, if they have like do you think they'll have like a web call? Or do you think they'll present it in a video format? Because it'll be tasty for us to watch them talk. Man, I'm just holding for years, man. I'm holding for years. I don't necessarily have a price target right now because the market's so volatile. It's all over the place. But if it keeps going down, I'm going to average down, baby. When we get a little bit of that YouTube cash peso. What's that? Nanbio Nano. Pack B plus Illumina plus ONT. Oh my. The Nanbio Nano. Are you talking the nano nozzle, baby? Is it what we're talking about? I really want to know what that nano nozzle's for, and I want to see when it's ready. So Simon from ARC said he's not hopeful for it, but man, I would love to prove him wrong. What if it can do long read sequencing, do you think, Messenger of Moistville? And is Fabian in here? I would love Fabian to tell us what he thinks of the nano nozzle. He also said that he had a dream about a customer base that could be super lucrative for us, and he doesn't want to say nothing to nobody. But yeah, guys. Oh, baby. Everybody's here. You stay drinking, cowboy. What you drinking? Whiskey? You had to sell bingo last week because you was on margin. Should you re-enter before or after earnings? Guys, what do you think? I can't give financial advice. I'm only an entertainer. But I don't buy I don't do calls and I don't do puts. I just buy the shares and I hold them for long term. But yeah. Messenger of Moistville? Oh my god. Now, what kind of sequencer is it? Can we do long read sequencing? That is the question. I really want Joe Butler to just tell me. Just tell me one tweet, baby. Do you think Firmo? Or do you think Firmo or do you think Illumina? This man here. Do you think Firmo Fisher or do you think Illumina? Who do you think is going to try and acquire the BNGO, baby? And is the rumors about SoftBank true? Did SoftBank come through and try and take control of our company? You know what? These earnings, you know, I'm not too sure, man. I think they'll be all right, but I think the best earnings have yet to come because after the symposium, Festival of Genomics, if you see what the kind of crowd was like there, oh goodness, all of the kind of hype and the buzz around it, and the guys were working hard. The sales team, Joe Butler was literally. I was tweeting to Joe. Joe was tweeting to me, and I was like, "What should I watch?" And he was like, "Oh, watch this one." And I was like, "Is there any next generation sequencing companies you're going to be in their presentation and you're going to speak and ask questions and this and that?" And then he told me where he's going to be. So I went in there on Festival Genomics and I was just watching him. I was literally just watching him, always writing, answering questions, clearing stuff up, and connecting with a lot of people. So yeah, I really like the sales process, the sales team, and how they're always connecting with people, having discussions. Sup, fellas? From Las Vegas. Come on, time to make some cash money, baby. We on the strip, baby. Las Vegas. Oh my, you're joking. Are you playing with me? Don't play with me, boy. Don't you play with me. Shall we get the little Twitter up? Let me get the little Twitter up and we're going to have a little looky. Did Simone say that? Mr. Simon Barnett. 4 tweets in the last hour. Let me click tweets and replies. Let me switch this over so we can have a little gander and see what this man's been saying. I'm going to share screen. Whoa. I'm going to go to there. We go to here. You ready to rumble? What has this man said? What? Cool idea. Would be nice if you guys, hey, SASPX, would be nice if you guys meet Erik Holmler for a one-to-one with an ArcG analyst, Simon Barnett, to talk about Bingo and Sapphire. Like this tweet and repost if you are Bingo. Oh, I like it and I'll retweet it for you. I'm sure a lot of investors would love it. Cool idea and wouldn't be opposed to it, but likely couldn't do that for compliance reasons. Come on, Simon, you're going to be a killjoy at the party. Come to the Bingo party. Yeah. Yeah, Shane, yeah. I hear you, boys. What are we thinking, guys? When do you think Simon's coming around for a Bingo cowboy tea? Cheers from Switzerland. Shout out, baby. I see you, baby. I think it's Mr. Investalot as well. Mr. Investalot is my Twitter, bro. Yeah. Oh, man. Oh, it's a Maui. It's a cheers from Switzerland. What's going on skiing down the slopes, fam B? We got a Maui Bingo cowboy. Yeehaw. What you can get for it now is nothing compared to where it will go. Earnings really do not mean much at this point. Yep. Still coming out of validation mode, but you can see how valuable it is. Oh, man, I gobble up that info. I gobble it up. Who's that? In the P. Leo advert is Peng. Are you in there, Mohammed? Are you inside AGBT? Do you guys want to watch something that I found interesting today? Alka has been dumping a lot of Pack B recently, more than if they were trimming profits. Ooh. Were they picking up anything else? Were they picking up 10x Genomics or anything else, or they just keep dumping and dumping? I wonder if there's another competitor on the market that they have their eye on, and maybe they want to throw a little bit in there. Taste it. Yeah, let's watch. You want to go in there? Sam playing emotions like a chick. Man, they keep sending those nudes, Glenn. All right, I'll tell you what. Let's take a little gander. Hold on. Let me get prepared so we enjoy. I want you guys to enjoy with me. So, what one was I watching? Was it?
Legendary Lab.
Oh no, not this one. It's not Pornhub. This is the one I was watching. I think this lady from ICANN. Oh, this was very interesting.
Even more.
Okay, we're gonna rewind you to the beginning. Can we get to the beginning? Yep. All right, guys, we're gonna have a little stream time. Are you guys ready to rumble? Let me prepare this. Bam, bam. And now you're gonna enjoy. Can you guys see?
AGBT general meeting in 2021. My name is Emer Kenny. I am the founding director for the Institute for Genomic Health and a professor of genomics and medicine here at the ICANN School of Medicine in New York City. And so today, the title of my talk is a little bit different than that's on the program. I really wanted today to focus on risk prediction and particularly thinking about the issues in an era of massive scale genomic data. So here are my disclosures. Okay, so I'm going to spend a little bit of time today discussing where we are in the field of genomic data, particularly its impact in changing the landscape of how we use genomic data for risk prediction. Some of the issues we currently face in our current knowledge bases. And then the last part of my talk, I really want to focus on what a look into the next 10 years and what I think we're going to face both in terms of opportunities, which are enormous, but also in terms of some of the challenges. So we really are in an era in the field of human genomics where genomic technology is generating hundreds of petabytes of information per year. So even in an increasingly data-rich world, it really is the case that genomic technology is driving some of our biggest and growing engines of information that we can then convert into knowledge. Here is one of those databases, and this slide now is a couple of years old, but this is the EMBL NHGRI GWAS catalog database that is at this point over 15 years old. And really from the inception of GWAS, when we were doing GWAS in the order of hundreds or a few thousands of individuals, which was such a huge achievement at the time, till today, when this database has grown to collect data from millions, hundreds of millions of humans linked to health outcomes, disease status, biomarkers, human traits, and over thousands and thousands of these, to really generate an enormous database of knowledge of human disease and biological function. And indeed, it has been a trove of information that really has advanced our understanding of biology and function in our species. But it turns out that the growth in the database has also become a very important tipping point for genomic prediction. Long story short, you need to hit sample sizes in individual studies in the order of millions of humans to achieve prediction that really starts to approach the upper limit of the heritable component, particularly for common disease. So this makes this moment in the field very exciting, and the application of genomics really has myriad possibilities, not only in research, but also in medicine and even society. However, with all that enthusiasm, I think we also have to be realistic about some of the challenges that we face as a field. This is one of them. This is a challenge that is the topic of research in my lab and many others, which is that genomics is failing on diversity. What I mean by that is the representation of humans in this large database, but also if you look at many other genomic databases of knowledge, is very biased toward representing a very narrow slice of humanity, specifically individuals of Northwest European ancestry, and very underrepresented for many other populations around the world. In fact, even lacking representation from many other hundreds of millions of humans on the planet. So one of the big questions that we asked in my group at this point several years ago, actually 8 or 9 years ago, is would this have any impact on our ability to use these knowledge bases for genomic prediction? And in a paper that we published in 2017 in the journal American Journal of Human Genetics, in work led by Alicia Martin, we were able to show both empirically using data from the 1,000 Genomes Project and also using simulation data that in fact genetic prediction accuracy does decay with increasing genetic divergence between the discovery population and the target population that you are applying the prediction. And here is an example of that for the human trait height, that if you were to take naively the read off of this plot here for polygenic risk, then you would predict, particularly for height, which has 80% heritable component, that many continental populations around the world are on average much shorter in stature than European populations. In fact, it's not true. We know a lot empirically about the phenotype of height. It's very easy to measure. There's usually much more variance in height across a continent than there is on average between continents. And at the time, really what we attributed this finding to was that what was happening here, that it was...
Yo, guys, I'm going to cut out too, man. Well, thank you very much for joining me, everybody. Love and appreciate you guys. Thank you to everybody that donated and helped us get into the into the general meeting tonight, because without you guys I wouldn't have been able to do it. So love and appreciate you guys, and thanks so much. I'm going to be putting some interesting stuff together. I think I'm going to watch through so many of those theatre presentations still. I'm going to compile that over the weekend, and also want to talk about the earnings coming up and future revenues too. But yeah, thank you for everything, guys, man. I appreciate you guys a lot. Oh, baby, long term. I'm holding it long and strong, baby. But yeah, guys, I just want to say good night to all of you guys. It's like nearly 12 o'clock midnight here. Oh, yeah, we about to do it. We about to do it, baby. Mr. Invest a Lot, over and out, baby. Thank you guys for tuning in. I love you guys. Thank you so much, and peace out. I'll catch you tomorrow. I'm still here, baby. Let me end the stream. Peace out, man. Good night, guys.